All right, so you know your way around relational databases.
Of course.
But today, we're going deep, really deep, into how to crank up the performance.
We're going to get those benchmarks off the charts.
Software optimizations, that's the secret sauce.
That's right. We've got 5 key areas we'll be diving into.
5. Okay, lay it on me.
First up, database structural diagrams, or DSDs as the cool kids call them. Then we've got partitioning strategies, column store versus row store architectures, always a fun debate, data compression techniques. And of course, the magic of in-memory tables.
All right, a lot to unpack there. But let's start with the DSDs. I get that they're like a visual map of the database.
Think blueprint.
Okay, blueprint. But how does that actually help us boost performance?
Well, think of it this way. A DSD can show you those bottlenecks before you even start the benchmarking process.
I see, so we can spot the trouble spots before they become a problem.
Exactly. Say you've got multiple relationships all pointing to one table. That's a red flag.
Right, because all those queries are going to be fighting for attention.
Exactly. And then your performance takes a nosedive.
Makes sense. Okay, so DSDs help us prevent those traffic jams. But what about when you've got those giant tables? You know, the ones that just slow everything down.
Ah, yes, those are fun. That's where partitioning comes in.
Partitioning? All right, break it down for me.
Basically, you're taking a huge table and splitting it up. Smaller, more manageable chunks.
Okay, so instead of one massive traffic jam, we have smaller, more organized lanes.
Precisely. And you can get creative with how you partition. Depends on your data and how it's accessed.
So like if you're working with customer data, you could partition by customer ID.
Exactly. Keep all the data for each client separate. Or you could partition by date. Lots of options.
So the strategy depends on the data itself. Got it. Now let's move on to how the data is actually stored. Column store versus row store.
Ah, yes, the classic showdown.
What's the difference and why should we care?
Imagine a spreadsheet.
Okay, I'm visualizing.
Row store is like storing data row by row, just like you see it in the spreadsheet.
Makes sense.
Now, column store is where things get interesting. It flips the script, stores the data vertically, column by column.
Okay, so we flipped the spreadsheet on its side. Why would we want to do that?
It all comes down to the type of queries you're running. Row store is great for grabbing individual rows quickly.
Like looking up a specific customer record.
Exactly. But when you need to do some heavy-duty analysis, aggregate massive amounts of data, column store is your winner.
Because it can access all the values in a column much faster.
You got it. Plus, you often get some nice space savings with column store.
Okay, so column store for analytics, row store for quick lookups. Now, what about when storage space is tight? I've heard data compression can help.
It can be a lifesaver. Shrinks that data footprint right down.
And I assume that also speeds things up.
Absolutely. Less data to move around means faster query times.
I like the sound of that.
But there's a trade-off. Compression does add a little bit of CPU overhead.
So we're trading a bit of processing power for faster storage and retrieval.
Exactly. It's all about finding the right balance for your specific needs. Different compression algorithms have different pros and cons.
So it's not a one-size-fits-all solution. But it sounds like it's definitely worth considering. Now, what if we could completely bypass the disk for our most important data? Enter in-memory tables.
Ah, yes. Speed demons.
Tell me more.
Instead of storing your data on a slow hard drive, in-memory tables live in RAM.
And RAM is way faster.
Orders of magnitude faster. It's like having your data on the tip of your fingers.
Okay, so we're talking about serious speed boosts here.
Absolutely. But there's a catch. RAM is expensive and it's limited. You can't just stick everything in memory.
So we need to be strategic about which tables get the VIP treatment.
Exactly. You got to analyze your workload, see which tables are accessed most frequently, and prioritize those.
So in-memory tables, incredible speed, but require some careful planning. Got it. I think we've covered a lot of ground here, but this is just the beginning. What's coming up next?
Well, we've talked about these optimizations individually, but in the next part, we'll see how they all work together, the synergy.
Sounds good. I'm ready for round 2.
It's really interesting how these optimizations all work together. They can create some serious synergy.
Synergy. I love it. Tell me more.
Okay, so let's say you've got this perfect DSD, all laid out, no bottlenecks, but your tables are huge.
And they're not partitioned.
Right. So you're still going to hit those performance walls.
It's like having a perfect map, but the roads are too small.
That's a great analogy. And that's where partitioning comes in. Widens those roads, keeps the data flowing. It goes hand in hand with that DSD.
So we've got clear roads, but now we need to think about the vehicles, column store versus row store.
Exactly. If you're running those analytical queries, column store is like a high-speed train.
Row store is more like a bunch of cars. Good for short trips, but not as efficient for the big hauls.
And then to make things even smoother, we can add some data compression, streamline those vehicles.
Okay, so we've optimized the roads, the vehicles, even the cargo. It's all connected.
And don't forget about in-memory tables. They're like teleportation.
Boom, data's there instantly. So it's not just about individual tweaks, it's about the whole system working together.
That's the key to database optimization. Look at the big picture, how it all fits together.
So we've talked about how these optimizations impact benchmarking, but what about real-world applications?
Think about a big e-commerce site right in the middle of a flash sale.
Thousands of transactions per minute. Their database must be working overtime.
And if it's not optimized, total chaos. Slow transactions, frustrated customers, lost sales.
So these aren't just theoretical improvements. They have a real impact on the bottom line.
Absolutely. A well-optimized database can make or break a company.
Now, we always hear about the importance of hardware. Bigger servers, faster drives, all that.
Hardware is definitely important.
But today, we're focusing on getting the most out of what you already have.
Exactly. It's like fine-tuning an engine. You can have all the horsepower in the world, but if it's not tuned properly, you're not going to win the race.
So these software optimizations are like the tuning tools for our database.
That's a great way to put it.
Sometimes a simple software tweak can be more effective than a whole hardware upgrade.
Before you go spending money on new servers and drives, look at your software. That's where the real savings are.
You mentioned earlier that DSDs can help you spot bottlenecks. What should we be looking out for?
Keep an eye out for tables with a ton of relationships. That's a classic bottleneck.
Like a busy intersection with traffic coming from all directions.
Exactly. Queries get stuck, performance suffers. You might need to simplify the schema or use partitioning.
So either reroute some of the traffic or widen the intersection.
Precisely. The DSD helps you make those decisions.
I'm starting to see how powerful these DSDs can be.
They're more than just pretty pictures. They're essential tools.
You know, when we first started talking about database optimization, I thought it was going to be all algorithms and jargon.
It can get pretty technical, but at its core, it's about common sense and planning.
Understand how the data is stored, how it's accessed, how it's processed. Then you can make smart choices.
Once you have those fundamentals down, you can start experimenting with different optimization techniques.
Experimentation is key. What works for one database might not work for another.
Absolutely. It's a process of continuous improvement.
Always looking for ways to make things better. Have you ever seen a database so messed up that it was beyond repair?
Oh yeah, definitely. Like a tangled mess of tables and relationships, no rhyme or reason.
Sounds like a nightmare.
Sometimes the only solution is to start over. Build a new database from scratch with optimization in mind from the get-go.
Like trying to renovate a house built on a shaky foundation. Sometimes it's better to just tear it down and start fresh.
Rebuilding a database is a big project, but sometimes it's the only way to achieve true optimization.
So what are the key things to keep in mind when you're designing a new database?
First, choose the right database management system. Some are better for certain tasks than others.
Right, tool for the job.
Then you need to think about your data model. How is the data structured? How are the tables connected?
It's like designing a building. You need a solid blueprint.
And once you have that model, you can start thinking about partitioning, indexing, storage formats, all those optimization techniques we talked about.
Plan ahead. Make smart decisions from the beginning. That's the key.
If you build optimization into the design process, you'll avoid a lot of headaches down the road.
We focused a lot on the technical side of things, but there's a human element to all of this too, right?
Absolutely. Database optimization isn't just about code and data. It's about understanding the people who use the database.
Finding that balance between technical efficiency and user experience.
You can have the fastest database in the world, but if it's not user-friendly, it's not doing its job.
So how do we understand user needs?
Talk to them. Find out how they're using the database. What are their pain points? What would make their lives easier?
It's like user research.
Exactly. Get feedback. Make sure your optimizations are actually helping people.
At the end of the day, it's about making the database work for the users.
Well said.
This has been a fascinating discussion. We've covered so much ground.
From DSDs and partitioning to column store versus row store and in-memory tables.
And we've just scratched the surface. There's always more to learn about database optimization.
The technology is always evolving, but the fundamental principles remain the same.
Understand your data, understand your users, and use that knowledge to build a database that performs at its best. I feel like I have a whole new appreciation for database optimization now. It's an art and a science.
It's been great sharing this with you.
And to all our listeners out there, if you're ready to take your database skills to the next level, dive into the world of optimization.
There are tons of resources available online, in books, and don't be afraid to experiment. That's the best way to learn.
This has been a fantastic conversation. But before we wrap up, I have one final thought-provoking question for our listeners.
Okay, I'm all ears.
We've talked about all these ways to optimize databases, make them faster, more efficient.
Right.
But what about the data itself?
You're bringing up a crucial point.
Even with the most perfectly optimized database, if the data is garbage, the results are going to be garbage.
Garbage in, garbage out. That's the saying.
So, as we focus on database optimization, let's not forget about data quality.
Absolutely. Clean, accurate, well-structured data. That's the foundation of any successful database.
It's like having a high-performance car, but filling it with low-grade fuel.
Great analogy.
So data quality is just as important as database optimization, maybe even more important.
I completely agree. It's the fuel that powers the engine.
I think that's a great place to end our discussion. Remember, folks, data quality matters.
And so does optimization. It's an ongoing journey of learning and improvement.
You know, we've been deep in the weeds here talking about all these optimizations, DSDs, partitioning, column store versus row store.
Even touched on those in-memory tables.
Yeah, speed demons. But something's been bugging me.
Oh, what's that?
We're so focused on squeezing every drop of performance out of the database.
Right. Efficiency is key.
But what about the data itself?
You're hitting on a really important point. We can't forget about the data.
It's like having this amazing high-tech kitchen, all the gadgets you could dream of.
Top of the line, everything.
But if the ingredients are rotten...
You're not making a good meal.
Exactly. No matter how optimized your database is, if the data is bad, the results are bad.
Garbage in, garbage out. It's a classic for a reason.
So data quality, it's got to be part of the conversation.
Absolutely. It can't be an afterthought. You need to think about data quality from the very beginning.
From how it's collected to how it's stored.
How it's cleaned, validated, processed. Every step of the way.
It's like building a house.
You need good materials.
Exactly. If the foundation is weak, the whole thing crumbles.
And just like a house, data needs maintenance.
So it's not a one-and-done thing.
Nope. It's an ongoing process. You got to keep an eye on that data quality.
Data quality is a journey.
Couldn't have said it better myself. So we've covered a lot of ground in this deep dive.
Database optimization, it's a fascinating world.
It's got its technical side, but it's also about understanding people, how they use the data.
And of course, we can't forget about data quality.
The foundation of it all.
If you enjoyed this deep dive, hit that like button, share it with your friends, and don't forget to subscribe to our channel for more deep dives like this.
We've got plenty more to explore in the world of data.
Until next time, keep optimizing. And remember,
data quality matters.